Okay, I'm going to bring you along and checking out what this Escalade is doing. It is a 2008 um, Escalade 6.2 liter, and it was brought to me from a buddy of mine from his shop. And it's actually doing something that I've not ever seen before, at least not to the extent that this one is doing. But it is not running great. It's had an engine rebuild done for it not running great. It still continues to run bad, and the consensus has been that there is a lot of crankcase pressure. Apparently the rear main seal keeps blowing out. It keeps either consuming or blowing oil out. But let me just show you what I've got. They've tried to, I guess, remedy this breathing problem in the crankcase with an aftermarket breather setup, which he tells me made no difference. One thing I want you to look at is the amount of oil, obviously mixed with moisture, that continues to come out from the intake. And actually, it gets bad enough, it starts to it'll pool up pretty bad on the floor. So there's obviously something going on. He tells me supposedly some updated valve coverings have been replaced on both sides, and again, a complete engine rebuild. I do not know exactly where to go with this, but I'm going to bring you along. And just like with any possible mechanical engine issue, I'm just going to start with a relative compression. Not sure whether it would show anything related to crankcase pressure, but I just want to see an idea of the mechanical state of all cylinders when cranking. Okay, so I'm all set up to do the relative compression. I just, for added measurements, I've got the intake pulses, exhaust pulses, ignition number 1, and then relative compression on the battery. Again, just to do a basic test, see what it looks like so we can go on from there. I've got the injector fuses removed, and I'm all set up to go ahead and crank it and see what it looks like. Okay, and I'm kind of glad I did that, because I don't know if you could pick that up audibly, but there is a mechanical situation going on with, just even by the way it sounds, how it cranks, which is kind of crazy, because once, and I haven't got a shot of this, but I'll get you a shot of how it runs, and it quote unquote runs not terrible, I'll call it. Not the best, but not like oddball sounding when it's idling. It is always a kind of a hard start, but then it'll run and then kind of idle. Like I said, I moved it around in the lot to bring it in. It kind of idled all right, which is kind of crazy based on what this is showing. Now, let's concentrate first on the battery trace. You can see right here, 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 here. It pegs up to the 600 amps, and that's that audible noise we were hearing, like a spin, 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 and then like a stop. So it's basically, it's fighting that, and then it continues, then it stops, it fights that, continues, so on and so forth, and it's obviously continuous. Let's try to break down and see where that is. Okay, so I've got it zoomed in to here. The red trace is my ignition sink, there and there, and then I've got my ruler set up. The firing order is 18726543. So this little hump here is going to be 1, and then supposedly, you know, we got 8726543 back to 1. And I don't know if you can tell very well, but the top dead center works or lines up there. It does not here, as far as the ignition occurrence timed off of number 1. There, as far as happening and occurring at the top dead center point, it's off. So this one, we can clearly see it's off. Something's going on here. It's building way too much compression. There's too much of a resistance there for spinning the engine. And ignition is happening when it thinks it's supposed to happen, most likely, and then the same here, but then that's off here, that's off, and then so on up until maybe this guy here, and then back to 1 where it looks like it's on. So something that's something to take note of. Now this whole situation, I've never come across a vehicle that runs decent and then has a terrible looking relative compression as far as that going on, and then the ignition's being off. But I'm sure this is throwing off a lot. Again, I'm glad I did relative compression, but this is what I'm starting off with. We're definitely seeing something, and then try to decide where to go from here. So actually what I've decided to do is I'm going to do another relative compression. I'm getting rid of the exhaust right now, and I've added that to ignition coil number 8 control. I just want to see the firing order of the coils and how the 1 and 8 look, especially compared with how the relative compression is looking like. So I'm going to go ahead and crank it and see what that looks like. Hopefully the battery lasts. Now, being that one cylinder goes all the way up to 6, it takes out a lot of juice, a lot of power out of the battery. So okay, so just for viewing purposes, I got rid of channel A. I wanted to see the yellow trace there, which is number 8 firing. And there is obviously there's coil control. And so it's happening right at that point, and that point. Let's bring the rulers, base it off of number 1 again. Now that's interesting. Let me zoom in here. So now, just going to go out on a limb here and try to explain. Now, So what we're seeing here with this ignition, with what we're seeing here with this ignition and this ignition here and the rulers here, the Pico, when you pull out these rulers and pick that point to this point, it's gonna equally space out these rulers in time in relation to this total time. It's going to break that all apart in equal spaces in time. The reason why these are not collaborating, sort of say, matching up, is because we are not rotating, cranking in a steady, continuous speed and pattern. We, at this point, because of the high rise, we are slowing the crankshaft down, and then it's going to throw the rest of the timing off until the speed catches back up. That's why the strike is later, more to the right of that ruler, because we've slowed this crankshaft down while it's climbing that hill. What this does prove, though, is a couple things. We do have the correct cylinders laid out. I am tapped in on ignition 1 and ignition 8, so we know that this hump here is happening somewhere in relation to cylinder number 8. So that's one thing. The other thing that this shows is our ignition being primarily based off of crankshaft trigger teeth. It also shows to be true because it didn't fire until that set of teeth that it looks for to fire again crossed that point, and then it fired. So we literally do know that the crankshaft slowed down, because then the trigger teeth slowed down until it hit the point, and then it hit the ignition. So we can sort of say we know our crank trigger and timing with the ignition and crank is correct. We are also trying to ignite the correct cylinder as far as firing order. So those are a few things that I wanted to try to explain. So now the fun task of trying to find out what the heck's going on here. And I also wanted to, right now at this point, at first glance, possibly explain or make sense of this occurrence there. That rise in the loss of vacuum there can be attributed to a few things. Obviously, if we have pressure rise from leaking intake valves, that can occur. But what I believe is going on here is the crankshaft slowed down, as we know that for sure. So it, in the intake manifold, it was basically just waiting until the crank and cam turned over to the point where a valve then is going to start opening, and then you have a pull going on. So I'm going to attribute that to a slowdown of the crankshaft, which let so much time go by before you have a pull. So there's a loss of vacuum. Pressure is rising, but it's not due to pressure being introduced into the intake manifold. It's just there was no activity, and so the vacuum you pulled is now lost because there's no pull until the next one pulls. Then you come down. So it's due to a delay or slowdown of the crankshaft that the pressure rose up, because nothing pulled on it until late. And also, this one is on compression, and it's building way high compression. I don't believe, again, because of that pressure is escaping into the intake manifold. There has to be a seal in that cylinder 8 chamber for it to create this high of a compression pressure, and the rise in pressure is just because no activity happened. It happened late. But if some were to bleed off at this high of a compression pressure into the intake manifold, it would be a greater spike, a nice shot of pressure, not a subtle just slow down and move over. So just to also negate the possibility of leaking intake valve while this one's on compression, which makes that rise, no, I believe that chamber is sealing. That's why it's making huge compression. And if there was a bleed off with this much pressure, it would be way higher spike than that. Now this is just a quick crude thing, and I'm only basing it off of what I've got here. We know number 8 is the one that is creating the high, super high compression pressure. Number 5, it's a companion cylinder, so that should be going up on exhaust. So one quick thing that I wanted to do is I removed the spark plug from number 5, and I will run the same capture, and I want to see what it looks like. Well, looks like nothing changed there as far as that high compression on number 8. We are still on number 8. I actually put the fuses back in for the injectors. I'm going to actually let it crank and run. Get you a shot of that and also see what it looks like. Alright, so it's a little bit hard to start. It's running rough right now. Just letting it idle. A little bit of gas. Now it's been quite a minute since I've last checked this one out, but the last of where I left it was cranking, getting that oddball cylinder on oddball compression on cylinder 8, and then I actually just let it sit. It's been sitting for quite a bit, and without cranking or anything, and I want you to look and see what it does now after sitting. So hopefully you can hear that. This is now locked up. I'm assuming it's going to be hydro locked. But this is, I was getting back on it to do some more testing, and I went to crank it over, and that's what I got. I don't know what the heck is going on with this again, but at this point I need to find out why and where it's hydro-locked, or try to get it unhydro-locked to see if I can continue to try to find an answer on this. This one's very weird. I've not ever run into a situation like this, so I'm kind of trying to just bring you along as we together find out what the heck the problem is. I just removed the spark plug for number 8, and look at that. I don't know what fluid that is. Looks like coolant. Yeah, it's wet. It's not wet with oil. I was kind of expecting, but that's water. Obviously, being that number 8 was giving me the high compression on relative, after having it being locked up after sitting for a while, I decided to just only pull number 8 out to just visually try to see something, and it looks like definitely that's the one that's hydro-locked. I actually let me try and crank it right now. Alright, number 8 coils unplugged. Let's just see if it'll turn over. Well, there must be more. That's after removing number 4. Same thing. Looks like coolant coming out of the spark plug hole. Here is number 4. And that's number 6. So all of bank 2 spark plug holes are removed. Let's see what let's see how it cranks. Cranks over. Okay, I've got all spark plugs out of bank 2. I'm gonna crank it over with relative and a sink, just to make sure the only humps we are hearing are gonna come obviously from here, and I want these to be at the same level, obviously just at different times in the relative compression. Okay, so that is what we've got with just bank 1 spark plugs in, and this is 1, this would be 8, this is 7, and then 2, 6, 5, 4, 3, back to 1. So only ones we are getting now obviously is bank 1, and the more I crank it, you can see now the more coolant, I guess, keeps getting pushed out, and it's a whole lot bigger mess down there. So mechanically this bank 2 seems to be having an issue with gathering coolant in the cylinders. At least 4, 6, and 8 Number 2, the plug seemed dry, but that's what I'm finding so far right now. I'm going to put the ejector fuses back in. I'm actually running 2 transducers bank to bank. I want to see if the cats are clogged, so I got the plugs back in. Mine is 1 on each bank. Hopefully it'll run enough to get a good measurement. Okay, so this is at the cranking event. Let me just drop down for reference a 0 point, and let's get started looking. This is during first crank, and it was kind of not wanting to idle, but just there at them points I could sort of see. This is the 0 point, and both these, the green and yellow, are scaled. Their starting point, the 0, and everything is the same. So the 0 point applies to both colors. Anything above it is the same amount above it, but that point, that exhaust ramp is that much higher off 0. That's when it was almost stalling. Actually, here's almost stalling, and then it dipped down because it caught itself as far as idling, and then it let me actually give it some throttle, but here when it caught itself, just to get a reference, above 0 right there, we are 3 pounds above 0 for both banks. On the exhaust ramp, like I said, I was wanting to look and check for a cat. Here at this point where we give it a high acceleration, the airflow, exhaust airflow should just flow, and that should stay down low. But as you can see, even here, they start climbing. Just for number of reference, at this point, that's 8 psi on the green. This next high green one, that one is 13. Let's see, here on the yellow, let's see, bring that down. So that's about 11 on the yellow, and like I said, 13 on the green. So on acceleration, or with giving it throttle, when it should move air through the exhaust, it is backing up like crazy in the on the exhaust ramp for each cylinder per bank, which tells me, and I had a hunch, that the cats are most likely the cause of the crankcase breathing issue. So what I believe that is going on is this. Apparently, this customer recently bought the vehicle, or they brought it to the shop that brought it to me. And I guess when he got it, it was not running right. That's why he brought it to that shop. And I bet that it had been misfiring at one point. At that point, already damaged the cat's bank to bank. So now we've got a breathing problem on the exhaust end, which now the engine cannot operate properly. It goes over to the shop. They do a rebuild for whatever reason, and then install it back in, and still has drivability problems. So now we've got a new rebuilt engine with a clogged exhaust bank to bank. It still is not going to operate and breathe properly. So that's one problem. That's going to create your crankcase pressure buildup in the crankcase, which then is overflowing in the breather and the oil, all that, and blowing the seals like it had been. Second, I'm wondering if because of that too much crankcase pressure or issue, it created a failure with the head or head gasket on this bank, or was it just not properly done during the rebuild on that side, because cylinders 4, 6, and 8 are all wet with coolant. I double checked, number 2 is the only dry one. This side is dry as far as spark plugs with coolant. Off camera, I did open that cap once I saw the coolant come out of all those cylinders, and there was an excess pressure noise, and once that was bled off, the coolant just sucked and it just drained down and went, I guess, down into the engine, whatever was lost into the cylinder. So there is a mechanical coolant system gasket issue there. Again, not sure if it was caused by the excessive backup in crankcase, backup in exhaust pressure, creating high crankcase pressure, or possibly head gaskets reused, or head bolts reused, or not torqued right, something on that end. So there's a couple things going on. Definitely one I've not seen or come across. The high compression on number 8 on the relative, I believe, is going to be due to us seeing the water buildup in that cylinder, creating that high compression pressure, and then the longer you let it sit, it fills up all the other ones to where you can't crank it because it's too full now. As we were seeing, number 8 was the one that fills up quicker, I guess. So starting off, that answers that from what we saw in the beginning, the high compression. And then just, I think ultimately the cat is the main contributing to the failure of the original problem, and then the secondary and third problem. And then obviously we've got a head gasket issues. I think that's kind of where I'm going to conclude this one. It obviously no need to go too much further, since we do know we have a major mechanical issue where it's going to have to be removed again, and the cat's going to have to be taken care of. But I hope you kind of understood the gist of this one and the path, and I hope it helps some of you guys down the line with when you see one cylinder oddballish like that. Maybe think about if there's possible fluid in there, uncompressible fluid in there, which is raising the compression on that one cylinder. So other than that, I'm just going to give the guy a call, let him know everything that he's got and all that needs to be done in order to rectify it. But that's it for this one.